All right, welcome back. So, next thing we're going to look at is basically 22 hundredths. It's 22 hundredths. Wow, that's taking up the whole screen. And if we had four groups of 22 hundredths, all right. And remember, think about this as money. If you want to look for reasonable answers, think about if you had four piles of 22 cents. Each pile of 22 cents is 2 dimes and 2 pennies. All right, so if you had 2 dimes and 2 pennies 4 times, how much money would you have? So with base 10, here's one of the ways you can look at it. They shaded in 22 hundredths on one of these models, and then they're going to give that same model to you 4 times. So that's 22 hundredths times 4. Here's another version where they just took 22 hundredths and put it into one base 10 model. So you have 22 hundredths 4 times. Each time they drew it in a different color. So there's 2200 shaded in pink, 2200 shaded in green, 2200 shaded in blue, and 2200 shaded in orange. Once again, making up a total of 88 hundredths. So both of these are representations of 88 hundredths. This is 88 hundredths in four groups of 22 hundredths. Here is 88 hundredths in four groups of 22 hundredths squished together in one base 10 model. All right, there is 22 hundredths 4 times. So this is the non-array version. Here's 2 tenths and 2 hundredths. Kind of what I made up here would be more like the array version if we had like more groups. This would be 2 groups. I do not have enough base 10 blocks in front of me to make 4 groups of 22 hundredths, but sorry, I'm trying to get this all to fit on the screen. There we go. So imagine 2 more of those groups. That would kind of be the array. These are just 2 tenths, 2 hundredths, 2 tenths, 2 hundredths, 2 tenths, 2 hundredths, 2 tenths, 2 hundredths. Remember, just think about that like 2 dimes and 2 pennies. And then there's the numerical form, 22 hundredths, just being repeatedly added 4 times. So all of these give you a total of 88 hundredths when you count them out. Next, we would be looking at 1 and 3 tenths. 1 and 3 tenths, remember, if we're talking about one whole, talking about 1 whole and 3 tenths. So I don't even have enough room on the screen to show you this with base 10, but it would be 2 groups of this. And I'm sure they'll draw you some pictures over here. Whoa, drew all the pictures all at once. All right, so there's 2 groups of what we're looking at on the right. 1 whole and 3 tenths. And if you squished it all together, it would look more like this. There's 1 whole and 3 tenths and another whole and 3 tenths. So together you have 1, 2, and 1, 2, 3, 4, 5, 6 tenths. Up here you have 1 whole, 2 wholes, and 1, 2, 3, 4, 5, 6 tenths. And here's another version of that, kind of what we're looking at over here on the right. 1 whole, 2 wholes, 1, 2, 3, 4, 5, 6 tenths. So all of these represent 1 and 3 tenths 2 times. And if we count it all up, it's 2 wholes and 6 tenths. There's the numerical form. And as you can see, there's 1 whole, 2 wholes, 1, 2, 3, 4, 5, 6 tenths. There's 1 whole, 2 wholes, 1, 2, 3, 4, 5, 6 tenths. There's 1 whole, 2 wholes, 1, 2, 3, 4, 5, 6 tenths. And then 1 whole, 2 wholes, 1, 2, 3, 4, 5, 6 tenths. All of these represent 2 and 6 tenths. So if you want to come back to the next video, I can show you how to use the algorithm to get the answers to the previous 2 problems. So come on back and I will see you then.